Hello everybody, this is Mr. Parker and we're doing question 7 on the OCR Core 2 paper from June 2007. To load more questions from this exam paper, click on the link here. Question 7 Part A. In an arithmetic progression, the first term is 12 and the sum of the first 70 terms is 12,915. Find the common difference. I've copied the formula for the sum to n terms for an arithmetic progression from the formula book. That's what you can see in this box. So we're going to use this to find the sum of the first 70 terms. In these two formulae, n is the number of terms that we're going to sum to, a is the first term, l is the last term, and d is the common difference, so what we're adding on to each term. We don't know the last term, so we're going to use this last part here that says half n bracket 2a plus n minus 1d. Let's begin by writing down the things that we know. The first term is 12, so we'll write down that A is 12. And we know the sum of the first 70 terms is 12,915, so we'll write S70 is 12915. So we're going to do the sum of the first 70 terms, which is S70. So on the left hand side we're going to get 12915, and that's going to be equal to this formula where n is 70. So we're going to get half multiplied by 70, that's the outside of the bracket. Then we're going to get 2 lots of A, which is 2 lots of 12, plus n minus 1 is 70 minus 1, so that's going to become 69D. Let's simplify this a bit. Half times 70 is 35. 2 times 12 is 24 plus 69D. Let's divide through by 35. So 12915 divided by 35 gives us 369. And that's going to equal 24 plus 69D. So to isolate D, we're going to subtract 24 and then divide by 69. So D equals 369, take 24 divided by 69. And if we do that calculation, we get 5. So D equals 5. Question 7, Part B. In a geometric progression, the second term is minus 4, and the sum to infinity is 9. Find the common ratio. In the formula book, you're given the sum to infinity for a geometric progression, and it says it's a over 1 minus r, and this is only valid when the common ratio r is less than 1. Like in the last question, a is the first term, s infinity here just means the sum to infinity. Again, let's start by writing down what we know. The second term is minus 4, so I'll write u2, that means term 2, equals minus 4, and the sum to infinity is 9. Notice at the moment we don't know the value of a or the value of r. Because we have two unknowns, we are going to end up forming simultaneous equations to solve. Let's just think about what we mean by a geometric progression. If I take any term, say I'll call it un, to get the next term, which I'll call un plus 1, I multiply the previous term by whatever the common ratio is. In this case, we don't know what that is yet. So using this here, I can say that u2 equals u1 multiplied by whatever the common ratio is. But u2, we know that's minus 4. Normally we say that u1 is the first term, so we call that a. So we get minus 4 equals AR. I'm just going to rearrange that so that it's A equals, so I'm going to get A equals minus 4 divided by R. So I've got one equation here involving A and R. Let's see if I can get another one using the sum to infinity. Well, all I've got to do is substitute 9 in here, so I get 9 equals A over 1 minus R. Now you might have been thinking here, why did I rearrange this to make it A equals? The reason is that I'm trying to find the common ratio. So if I rearrange this to get the letter I want to eliminate, then I can just substitute this value for A into my other equation. So I get 9 equals minus 4 over R, and that is all divided by 1 minus R. In order to progress from here, you need to know how to deal with fractions that are stacked on top of other fractions. And I'm going to show you a general rule over to the right here. If I've got some number a over b, and I divide that by c over d, so one fraction divided by another fraction, I can think of that as a over b divided by c over d. The trick for dividing fractions is to take the reciprocal of the second one and then swap the divide for multiplying. So I get a over b multiplied by d over c, which if I simplify that algebraically, I get ad over bc. So this is a general rule about what to do when you need to divide any fraction by another fraction. The way I remember it is I times the top and the bottom numbers together and the two middle numbers together, and I get AD over BC. However, the problem here is that I only have 3 parts to my fraction. The way I can resolve that is by taking this 1 minus r and rewriting it as 1 minus r over 1. Because dividing by 1 doesn't have any effect on the overall calculation. Now I can use this rule I've just shown, so I get 9 equals 1 times minus 4, which gives me minus 4, divided by 1 minus r multiplied by r, which I'll write as a bracket. For the next step, I'm going to multiply both sides by the denominator of this fraction, and that's going to give me 9 lots of r bracket 1 minus r equals minus 4. Expanding the bracket on the left gives me 9r minus 9r squared equals minus 4. And if I rearrange this to make it equal 0, I'm going to add 9r squared to both sides and subtract 9r. I get 9r squared minus 9r minus 4 equals 0. To factorise this, I'm looking for two numbers that multiply to give AC, so that's 9 times minus 4. So they're going to multiply to give minus 36, and they're going to add to give b, which is minus 9. So that's going to be minus 12 and positive 3. So I'm going to write my bracket as 9r and 9r, and I'm going to put minus 12 and plus 3. Now I'm going to look for common factors in both these brackets. I can divide this one by 3, and that gives me 3r minus 4. And I can also divide this one by 3, and that gives me 3r plus 1. So my two brackets here, I get 0 equals 3r minus 4 and 3r plus 1. So my two solutions for r will be r equals 4 over 3 and r equals minus a third. However, whenever we have a sum to infinity, the modulus of r must be less than 1. So we can say as mod r has to be less than 1, r is going to be negative 1/3. And that's our final answer.